Hello, my name is Georg Simon Ohm. I was a German physicist and mathematician, best known for my work on electricity. I was born on March 16, 1789, in Erlangen, Bavaria, in what is now Germany. My father, Johann Wolfgang Ohm, was a locksmith and a largely self-educated man who encouraged me to study mathematics and science. From a young age, I developed a strong interest in mathematics. My early education gave me a strong foundation for my later scientific work. I studied at the University of Erlangen, where I continued my studies in mathematics and the natural sciences. In 1811, I received my doctorate. I then worked as a teacher while continuing to develop my scientific knowledge. Teaching mathematics and physics allowed me to share knowledge while also giving me time to investigate important scientific questions. During this period, I became particularly interested in electricity and the way electrical current moved through conductors. I performed careful experiments, changing electrical conditions and recording the resulting measurements in my laboratory. I compared measurements of electrical potential and current, searching for a mathematical relationship between them. After many experiments and calculations, I found a consistent relationship between voltage, current, and electrical resistance. In 1827, I published my major work, The Galvanic Circuit Investigated Mathematically. I found that, for a conductor under constant physical conditions, increasing the voltage caused the current to increase proportionally. This relationship became known as Ohm's law. It connects three important quantities: voltage, current, and electrical resistance. Voltage equals current multiplied by resistance. V represents voltage. Voltage provides the electrical push that drives current through a circuit. I represents electric current. Current describes the flow of electric charge through a conductor. R represents resistance. Resistance opposes the flow of electric current through a material or component. If the voltage remains constant, increasing resistance reduces the current. This demonstrates another part of the relationship. To verify Ohm's law, we use a battery, resistor, ammeter, voltmeter, rheostat, switch, and connecting wires. The ammeter measures electric current, so it must be connected in series with the component. The voltmeter measures voltage across the component, so it is connected in parallel with the resistor. By changing the rheostat, I can obtain several pairs of voltage and current readings and compare them. For each reading, resistance can be calculated by dividing voltage by current. A nearly constant value verifies Ohm's law. When the measurements are plotted on a graph, they form a straight line passing through the origin. Recognition came gradually as scientists continued studying electrical phenomena. The experiment shows that voltage and current are directly proportional when resistance and temperature remain constant. In 1827, I published my major work on the mathematical treatment of the galvanic circuit. The ammeter measures electric current, so it must be connected in series with the component. This diagram. Over time, the importance of my research became clear, and my contribution to electrical science was increasingly recognized. The principles I studied became fundamental to electrical engineering and modern electronics. Today, the SI unit of electrical resistance is called the ohm, represented by the Greek letter omega, in my honor. Engineers use the relationship between voltage, current, and resistance when designing and analyzing countless electrical circuits. My experiments helped establish a mathematical way of understanding electrical circuits, connecting physical observations with equations. I am Georg Simon Ohm. My name lives on through Ohm's law and the unit of resistance. Thank you for learning about my life and scientific journey. My story shows how careful experiments, mathematics, and persistence can lead to discoveries that influence science for generations.